Hey everyone, welcome back to Horse Patterns. In our last video, we explored domain model patterns and key techniques for structuring and maintaining your domain, like repositories, domain services, and factories. But there's another powerful pattern we haven't covered yet, the domain event pattern. We set aside a whole video for this because it deserves a deep dive. Today, I'll explain how the domain event pattern works, why it matters, and walk through an implementation example so you can see it in action. Let's jump right in. What is the domain event pattern? The domain event pattern is a cornerstone of domain-driven design. It's all about modeling significant events or changes within your business domain. Think of a domain event as an immutable data structure, describing something important that just happened, like order created or user registered. The main goal? Decoupling. The pattern lets different parts of your system communicate without being tightly linked together. The code that raises the event doesn't need to know who or what will handle it. This makes your system more modular, scalable, and flexible. Let's go over the key components of the domain event pattern. A domain event represents a business fact. Something happened. It's typically just data, like a timestamp and the affected entity's ID, and it's always immutable. For example, an order was placed. The event publisher is responsible for publishing domain events. It decouples the producer, like an order service, from consumers. Events can be published synchronously or asynchronously. The event consumers, handlers, are components that react to specific events. For instance, when an order is placed, you might want to send an email or update analytics. In distributed systems, events can flow through messaging systems like Kafka or RabbitMQ, for example, allowing cross-service communication. So what are the benefits of domain events? Loose coupling. Producers and consumers don't need to know about each other, reducing dependencies and making the system easier to change. Scalability. You can handle events asynchronously, so your system can process more work in parallel. Extensibility. Adding new event handlers is easy, with no need to touch the code that produces events. Traceability. Events leave a clear audit trail, so you always know what happened in your system. Alright, let's walk through a simple example of the domain event pattern in action. I'll guide you through each piece of code, so you can see how it all fits together. Step 1. Order message. Let's start with this little class, order message. Think of it as a simple container that holds information about the order, like its ID and current status, making it easy to share these details with other parts of the system. It also gives us a handy way to turn an order object into an order message. So, whenever we want to share what happened to an order, we just package up the details with this class. Step 2. Order created. Next up is order created. This is our domain event. Imagine it as a message that carries important information about the new order, so other components in the system can react or process it as needed. It keeps track of a unique event ID, the order details using order message, when the event happened, and it has a factory method to make creating these events easy and clean. Step 3. Order. Now, let's look at our main business object, order. This is the central object in our system that represents an order. It keeps track of the order's ID and status, and provides a factory method to create new orders. As the main domain object, it's also the right place to put any business rules or logic related to orders. Step 4. Order service implementation. Now comes the really interesting part. Here's our service class order service implementation. This is what actually handles creating orders in our system. Watch what happens in the create order method. When we create a new order, we immediately create an order created event. We fill it with all the order's info and the current timestamp. Then, instead of doing anything with that event directly, we hand it off to a message publisher. Why? Because with the domain event pattern, the service that creates the order doesn't need to know what happens next. The message publisher might send an email, update analytics, notify another system, whatever needs to happen. But our service doesn't care. It just raises the event and moves on, which is the beauty of decoupling. And now that we've seen how the code is structured and how the event is published, let's see how it all works together in practice. When a new order is created through an HTTP POST request, the service receives the order data, creates the order, and immediately triggers an order-created domain event. This event is then published to Kafka, making it available in the appropriate topic. Other parts of the system can now consume this event and react to it, for example, by sending notifications or updating analytics. In conclusion, the domain event pattern gives you a clean and efficient way to design systems that are extensible, scalable, and easy to maintain. It really shines in complex domains or microservices, where you want to react to changes without tightly coupling all your code. By capturing business events as immutable facts, you enable a richer, more auditable, and more modular architecture. Have you used the domain event pattern in your projects? Let me know in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more awesome software design content. Thanks for watching, and I'll see you in the next one.